This is Geometry A, Unit 5 on transformations, Lesson 1, Translations. There are three kinds of transformations that keep shapes the same. They are translation, reflection, and rotation. There is a fourth transformation called a dilation that does not keep the shape the same but causes it to shrink or grow. And that's for a later subject, later topic, later presentation. We're going to look specifically at translation. Translation means a slide. Translation is a slide. It's when an object starts at one place and moves to another by sliding. Okay? So it can move to the right or the left, it can move up or down, or any combination thereof. It is not when we spin it, and it is not when we flip it. Those are different kinds of transformations. So I'm going to graph a point or a shape on here. I'm going to graph a triangle. Okay, so here's my triangle. Okay, and I'm going to label the points A, B, and C. A, B, and C. Okay, and let's indicate the coordinates of each of those points. Now we're using a Cartesian coordinate system, an XY coordinate system, in which the x-axis goes left and right, the y-axis goes up and down. Positive numbers on the x-axis go to the right, negative numbers, negative coordinates go to the left, positive y-coordinates go up, and negative y-coordinates go down. So A is 0 left and right, and 2, 4, 6 up. B is 2, 4 to the right, and 2, 4 up. C is 2 to the left, negative 2, and 2 up, positive 2. So the coordinate of A is 0, 6, coordinate of B is 4, 4, the coordinate of C is 2, 2. So I'm going to do a compound translation. I'm going to slide this triangle to a new location. Okay, and I'm going to move it so that I'm going to move it 3 spaces to the right and 2 spaces down. 3 spaces to the right and 2 spaces down. So 3 spaces right and 2 spaces down. 3 spaces right and 2 spaces down. So I just did a transformation, 3 to the right and 2 down. Okay, I'm going to call this point A prime, this point B prime, and this point C prime. Use a little hatch mark to indicate the new. And there's some vocabulary associated with this shape here. The green triangle is called the image of triangle ABC. The image is after a transformation, in this case a translation, which is a slide. So we have the original object and we have its image. So A prime, B prime, C prime. So A, B, C goes through some transformation and becomes A prime, B prime, C prime. ABC, triangle ABC, is called the object. And triangle A prime, B prime, C prime is called the image. So the image always refers to after the transformation. Okay. Now I want to list the new coordinates of A prime. A prime, if I look at it, is 3 to the right and 2, 4 up. 3, 4. B prime is 2, 4, 6, 7 to the right and 2 up. And C prime is 1 to the right and 0 up. Okay. Now I want to list these coordinates off to the right here a little bit and take a look at what happened. So A is 0, 6. B is 4, 4. And C is negative 2, 2. Okay? And through transformation, A became A prime, 3, 4. B became B prime, 7, 2. C became C prime, 1, 0. And the question is, what happened? What happened to the numbers? Well, if I look at the x's, 0 became 3, so it added 3. And 6 became 4, so it subtracted 2. Okay? 4 became 7, so it added 3. 4 became 2, so it subtracted 2. Negative 2 became 1, so it added 3. And 2 became 0, so it subtracted 2. You notice with each, we added 3 to the x-axis, so whatever x was, we added 3. And we subtracted 2 from the y. We added 3 to the x, we subtracted 2 from the y. We added 3 to the x, we subtracted 2 from the y. Okay? So in order to take and move this thing to the right, we took whatever x was and we added 3. And then to move it down to, we took whatever y was and we subtracted 2. Okay? So there's a way that we write this notation. Every point xy becomes, through a translation, x plus 3, y minus 2. And that's really kind of cool. That gives us a rule that we can use to translate, to slide something 3 to the right and 2 down. We add 3 to the x-coordinates, we subtract 2 to the y-coordinates, and it moves down. So this is the notation we use for a translation, and you're going to want to be familiar with this. So if we add to the x, we move to the right. That many spaces. If we subtract from the y, we move down, because y goes up and down. Move down. Now I want to explore this just a little bit in Desmos, because Desmos is really kind of cool the way it operates on this. So I'm going to put in a table. I'm going to put in a table the coordinates that I listed for the red triangle ABC. So 0, 6. B was 4, 4, and C was negative 2, 2. And then I'm going to put in 0, 6 again to close it. And I'm going to make it graph in red like we did. And I'm going to make it draw lines between the points. Okay. And I'm going to make a standard graph here. Standard graph. There we go. All right, so there's my triangle, right? Yeah, pretty much. Okay. And then what I'm going to do is I'm going to make a new shape, but I'm going to define some variables. I'm going to say, well, I'm going to let A equal 3, and I'm going to let B equal 2, negative 2, negative 2. So we're going to slide it right 3 and down 2. So I'm going to make a new table. New table, and this time all the x-coordinates, okay, I'm going to start with 0 and I'm going to add a to it. 0 plus a, 4 plus a, negative 2 plus a, and 0 plus a again. 0 plus a. So add a to all the x-coordinates and add b to all the y-coordinates. Now b is a negative, but adding a negative is subtracting. So 6 plus b. Okay. 4 plus b. 2 plus b. And 6 plus b. 6 plus b. Okay. And I'm going to make it blue, and I'm going to draw lines. And there's my translated triangle, just like in my hand drawing here. By adding 3 to all the x's, it moved 3 to the right. By adding negative 2, which is subtracting to it, moved down 2. Now what's really cool about Desmos is I can take and change those values. So as a gets bigger, it moves further to the right. As a gets smaller, it moves further to the left. So I can literally toggle this thing and move it left and right. Right? If I toggle B, because B was added to the y coordinates, it moves it up and down. Okay? And we can animate this. And animate this and cause the triangle to dance all around here. There we go. Okay, and we can have a little bit of fun with it by changing the speed at which it moves. Okay, and there we go. All right, so you can imagine applications of this. This has massive applications to computer graphics and computer programming and online gaming and things of that nature. This is the very way in which your computer simulates reality. It uses formulas and polygons to calculate the location of pixels on the screen and can change them over time. So a lot of fun. All right.